Right, in this segment we want to take a look at a few rules that are used in working with logs, and they're going to be especially helpful to us when we get to solving equations. The first one's the product rule, and it says log base A of the product mn is equal to the log base A of the m plus the log base A of the n. So in other words, if I have the log of a product, that's equivalent to taking the sum of the individual logs of those. Okay, it's based on exponent rules. You remember that if you have x to the m times x to the n, same base here, then you would just simply multiply that, show that multiplication by adding your exponents there, right? It's what we're really doing here. So log base 4 of 6 plus log base 4 of x could be condensed down to just log base 4 of the 6 times x. Same thing here, if I have log base 3 of y squared plus log base 3 of 5, I can condense that to log base 3 of 5y squared. Notice they all have to have the same base within that, that line. What if I want to do the other direction? If I have a product and I want to split it up, log base 5 of 25x could be split up as log base 5 of the 25 plus log base 5 of the x. But this first one we actually know, right? Because the answer to this is what exponent, what power do I put on 5 to get 25? In other words, how many times would I multiply 5 with itself to get 25? The answer would be 2. So simplify it if you can. If I have ln of 4e, I could split that as ln of the 4 plus ln of the e. Now remember that ln is the natural log, and even though it's not written there, I know the base on this is e. So ln of e is saying what power, what exponent you put on an e to get an e. Of course, you put a 1. Let's take a look at the next rule. It's called the quotient rule, and this time it's log base a of the quotient m over n. So this time we're going to take log base a of m and subtract log base a of n. And again, it's like our exponent rules. When you're dividing, you subtract the exponents. So when I've got the log of a division problem, I'm going to subtract those logs. So log base t of 8 over w could be split up as log base t of 8 minus log base t of w. Or if I have split apart and I want to be able to combine them, because I don't know the answer to either of these two, right? Log base 3 of 45, I can't think of a power exponent I'd put on 3 in order to get a 45. Let's combine it and at least make it look nicer. So log base 3 of the 45 over 5, well, I know that, that's 9. So log base 3 of 9, wait a minute, what power do I put on 3 to get the 9? 2. So therefore the answer here is just simply 2. One last rule. It's called the power rule. It says log base a of m to a power p is equivalent to taking that exponent p, putting it out front, and multiplying it with my log. So you bring the exponent out front and multiply it. Log base log base b of 5 to the x could be rewritten as x times the log base b of 5. We're going to use this one tons. Okay, 4 times log base 2 of y. Well, that 4 could be brought inside as the exponent on the y, and we'd write it log base 2 of y to the 4th.